Welcome to Car to Infrastructure Communications Emergent Technology presentation by Brandon Nielsen for MIS 580 Washington State University MBA program. Car to Infrastructure Communications, or CTI, is a technology that would have to be shared widely by many in order for it to work. But we're going to discuss that in this presentation. So, basically, what is car to infrastructure communications? Cars can speak with infrastructure devices, traffic lights, gas pumps, and even each other, including parking assistance type facilities and even others. This creates some safety, convenience, and better traffic flow, and even better emissions and fuel economy, as you'll see in our presentation. So how does car to infrastructure work? Basically, the car uses 3G wireless information technology, as well as Wi-Fi, as well as near field communications to communicate with various different other mechanisms like infrared traffic beacons. These would be placed well ahead of traffic signals, and the car and the infrared beacons, let's say for the traffic signal, would communicate. It would tell the traffic lights that this car is coming and at what speed. It would then very quickly communicate back to the car whether or not it was going to need to stop, or if it was going to go ahead and send it through the intersection. This creates a mechanism for fuel economy as well as traffic flow. So, data on a stationary or low speed vehicle ahead is also going to be detected by the infrared data sensors. So that can also tell your car that, hey, we have a slow moving vehicle or even an obstruction coming your way. And that would then give you enough warning to either change lanes or slow down appropriately. But basically, we're using two ways type communications between what we call infrastructure, that would be stationary devices that have communicating protocols, and your car, which is a motion mechanism that is going to be outfitted with, like we said before, 3G Wi-Fi, and near-field communications. So we're going to show just a quick example of how basically this would work. As you'll see that the traffic light actually has a infrared beacon on it, and it's actually communicating to the car on the right. See the traffic signals start and both vehicles go. But what you're going to notice is that the vehicle on the left is racing between lights. We've probably even done this ourselves. But the car on the right is actually communicating with the traffic signal up ahead, and it's going to say, hey, I'm coming through, and it gives it a green light. So it didn't have to speed up, it didn't have to slow down, and it was able to maintain better economy of both fuel, speed, and just traffic flow. So we know starts and stops cause that. Now look, it sends it through again and had a green light. As soon as it's through, it's giving it a yellow light, then red, and the other car has to stop. So we're going to see how it works in a parking lot next. You can see that those parking signals are actually communicating out at this point to an Audi. Now this is in German. I happen to speak German. So it says, Bitte fahren Sie bis zur Schranke. So it says, go ahead and travel through. There is parking. There is a parking space. So it's communicating. It's letting it through. And it actually even probably communicated to it what floor and what aisle to go park in. So you didn't have to go run around looking for parking. Now it's also going to help when you leave, because in this technology, in this case, we don't know. It's probably going to be Wi-Fi or near field, but it's saying, hey, Ihnen würden 3 Euro in Rechnungen. That means, hey, it was $3, and the car happens to have your credit card information in it, and it's passing the data through and making a subtraction on your account, and you just paid, and you basically didn't have to do anything. Now let's look and see how it works in a gas station fill-up scenario. So these are smart pumps, let's say at a Shell gas station. You pull up, you're communicating probably with near-field communications or Wi-Fi. It says, hey, you're on pump 3. Bitte wählen Sie der Zapfsäule. Let's see, bitte bestätigen Sie die Zahlungen der folgenden. And then, so basically what it said is that, hey, this is the gas, this is, do you want to use this credit card information? And you're controlling a joystick in your car. It says, yeah, go ahead and use that. And it says, go ahead and credit's been approved. Go ahead and fill up. You get out, you fill up, you put the thing back in, and you go. So basically, you're not having to swipe your credit card information. And we know there's been a lot of fraud with that. Now, this also has red light stopping assistant. Now, in not every case is your car going to be able to make the light switch. There could be already traffic happening. So we're going to see what's going to happen to the car if maybe you weren't paying attention and there is a red light. That looming red light. So here you're driving and you're not paying attention maybe, and there's a red light. Well, the sensor's going to come on and say, hey, be aware there's a red light. And it's actually going to stop the vehicle for you if you're not paying attention. Now that's pretty neat. We'll see another angle of this too, how quickly this thing's going to be from driving to slowing down. Watch this. And that was the kind of that smart technology that this is going to enable in your car. So what's the future? Well, we know the future for car to infrastructure means that cars can talk to cars. We know that there's going to be other traffic on the roads, like in this case, there's buses, emergency vehicles, even light rail. And all of these things will mean that their infrastructure is going to have to be updated. And such a system would grow more robust over time. Technologists are going to find more ways of increasing its effectiveness. And data analysis is going to probably prove that the systems prevent accidents. And it's only a matter of time before all new cars will have to include car-to-car and car-to-infrastructure communication. The system might eventually be mandated and probably be built by many different companies to a uniform standard. So for such a system to work, it's critical that each car, regardless of its manufacturer, can be understood by every other car on the road that is equipped with the same system. It will take at least 10 years for the infrastructure to catch up with this, but car-to-car communications is probably going to happen sooner. So, disadvantages and challenges. We know that the U.S. Department of Transportation in the report forecasts that the biggest hurdle are disjointed efforts by car manufacturers. And the real next step and hurdle is going to get car manufacturers to agree on how to do this. The next problem is funding for testing projects and planning overall infrastructure changes and costs. So this will be something that planners, I happen to be planning and zoning commissioner in our town, that I'm going to bring up. Hey, are we thinking about car to infrastructure type technologies as we do our master planning for some of our roads and other infrastructure? So that's the end of our presentation. If you have any other questions, I'd love to answer them. Go ahead and email me at the email address below. Hope you enjoyed our presentation, and we'll catch you next time. Thanks.